Ladies and gentlemen, hello, welcome, coming to you once again, not quite live from One Take Studios, where we are talking about slopes today, and specifically slopes of parallel and perpendicular lines. So again, it's all in the details, so make sure that you're taking some good notes, okay? Alright, so first up, we have parallel lines. What are parallel lines? Alright, so lines on a plane. What's a plane? Alright, not the thing that flies in the sky, but a flat surface. So we're talking about lines on a flat surface, like a sheet of paper or a whiteboard or something, that do not cross. So that is the main feature of parallel. Parallel lines do not cross each other. So what can we figure out from that? Alright, I have a delightful picture that is very blurry today of a graph, and I have a single line on it right now. So parallel lines, you cannot have one line by itself that's parallel. That doesn't make sense. That doesn't work. But if I wanted to draw another line in this graph that is not going to cross this one ever, it's on a flat surface, it's on a piece of paper, so that part's fine, where would it have to go? Because, like, if I do this, it'll cross the line, so we don't want that. If I do something like this, even if it's not crossing the line yet, if these lines keep going, they'll cross eventually. So where do I have to position this other line so that it will never, ever, ever cross? It would need to be running right alongside it, yes? It would need to be the same angle, the same slope. All right, so let's take a look at this, shall we? I'm going to put this right here because I think that's about as good as I can get for getting a line that's parallel to my first line. So here's my line. There we go. Oops, didn't mean to hit that high. That's okay. And go back it up a little bit. Or with my pen that's supposed to erase, that's not really erasing right now. Excellent. All right, now, can I be sure, absolutely sure that these two lines will never cross? Well, if they're at the exact same angle, the exact same slope, then yeah, we're good to go. So let's take a peek with this line right here. In order to get from this point to this point, I would need to go up 2 boxes and over 3 boxes. So my rise is 2, my run is 3. What about going from this point to this point? Up 2 boxes, over 3 boxes, my rise is 2, my run is 3. Both of these lines have a slope of rise over run, 2 over 3, 2/3. Because they have the same exact slope, they are parallel. Still don't like the fact that I can't erase that. That makes me so sad. I'm sorry. I didn't mean to mess that up. All right, so what we are saying here, parallel lines have the same slope. Please be careful, the word slope has an E on the end. Many people write slop because they're sloppy. All right, so same slope, parallel lines right there. Parallel lines have the same slope. This is something that you should know. What does that mean about perpendicular lines? What even are perpendicular lines? Well, okay, perpendicular lines, again, lines on a plane. So again, we're talking about lines that are on a flat surface that intersect to form a right angle. What is a right angle? It's something that makes 90 degrees. Okay, so what might that look like? Again, I started with the same drawing. Where can I put a line? It's going to cross, but it's got to make a right angle. What would a right angle look like? How do I make this happen? Have you seen the corner of a piece of paper? That's a 90-degree angle. I want to make an angle that looks just like that, where it's 90 degrees coming from one line, going to the next line, going across. All right, so that right there actually looks like a pretty decent spot. Actually, I need to, just slightly. There we go. There we go. And perfect. Draw. There we go right there. All right, these two lines are perpendicular lines. If I take my corner of my piece of paper, it slides right in there, perfect 90 degrees. So that is what perpendicular looks like. What does that mean about their slopes? If parallel have to be the same angle, the same slope, so the same number, what are these? Are these also the same? I don't think so. Again, if I start here and I go to here, this is the same line I started with up here, so that goes up 2 blocks and over 3. So this line has a slope of 2/3. From here to here, up 2 boxes, over 3. Rise, run. What do I know about this line, however? From here to here, I would need to drop 1, 2, 3 boxes, and then run 2 boxes over. Dropping 3, running 2. What does that mean about my slope? We're going down 3, so my rise is technically going to be a negative 3, but we are still going to run 2. Down 3 over 2. What do you see here? What's the relationship between these two? We've confirmed this is definitely a 90-degree angle, so these are perpendicular. That's a negative 3 over 2, and that's a 2 over 3. Can you come up with 2 words for me? Perpendicular lines have, well, let's see, one's positive, one's negative, so opposite. They're opposites of each other. And that's 3 over 2, that's 2 over 3, so they're flipped over. The fancy word for that is reciprocal. Make sure I spell that correctly. They have opposite reciprocal slopes. That's it right there. Opposite reciprocal for perpendicular. Please note, be very careful. Most people remember one word or the other. They have to be opposites, one positive, one negative, and they have to be flipped over from each other. If it's opposite but not a reciprocal, it doesn't count. If it's a reciprocal but not opposite, it doesn't count. All right, so these are the key things right here. Make sure that you can find this and this real easy in your notes. You can consult that later. What I want to look at on my next page is what might that look like for applying this. Oh, shoot. I don't want you peeking. I'm going to move my paper. There we go. All right, so how do I make this happen? I'm going to start with this right here. Perfect. There we go. All right, so I have a set of 6 different equations of lines, and I'd like to know which ones are parallel. Well, if I'm asking which ones are parallel, I'm actually asking which ones have the same slope. So which of these have the same slope? This line is y equals mx plus b. It's going to be really helpful to know your forms here. This is going to be our slope-intercept form. And in slope-intercept form, this is my slope, the one in front of the x. Do we see anything else here with a slope of 3? This one has a slope of 1/3. Does that even have a slope? What about that one? That's kind of weird. We'll come back to those. What about this one? This is slope-intercept form. This is point slope form. Y minus y sub 1 equals m times x minus x sub 1. This has a slope of 3. This has a slope of 3. Ladies and gentlemen, if I were to graph this line right here, it would be parallel to this line right here. They are parallel to each other. This one has a slope of 3. This one has a slope of 3. This one has a slope of 1/3, so it's kind of out. It's not the same as anything else. Now, I threw in some weird ones here because it's worth practicing with some of the weird ones. This is x equals 1. What on earth is that? Do you know? That's actually a vertical line, a line that goes straight up and down. And y equals 5, that's a horizontal line. I need to draw a slightly larger sketch. Horizontal line goes this way. So anytime I see x equals a number, I'm talking a line that goes straight up and down. And anytime that I see y equals a number, I'm talking a line that goes straight across. Notice this equation has a y and no x. This one has an x and no y. That's how we can tell them apart. Okay, do you know anything about the slopes of those? Something that goes back and forth like this does have a slope. It has a slope specifically that is 0. And a vertical line that goes straight up and down has no slope at all. It is undefined. I'm going to abbreviate UND, but undefined. It has no slope at all. So, are there any things here that I can pair? Is there another pair besides these two that also have the same slope? Did you see this one over here? What do we know about this one? This is y equals 2, which looks a bit like y equals 5. Note the numbers are not the same, but if this is horizontal, guess what this is? Also horizontal. And if it's also horizontal, then it will also have a slope of 0, which means, guess what? This one is parallel to this one. They are both horizontal. They both go straight across the page. Boom, like that. And they will never cross each other. All right, so parallel lines, same slope. It helps to know your forms to be able to figure out which is which, and it helps to know about vertical and horizontal lines too, because a lot of people struggle with those. So make sure that you get some good practice and some good notes about those things. All right, so next question, which lines are perpendicular? Uh-oh, what are we going to do this time? Well, let's see here, folks. Again, I've got 6 equations looking for the ones that are perpendicular, which means I don't want the same slope this time, but I want, what are the 2 words? Opposite and reciprocal. Opposite, reciprocal. So, what do we know about that? Yeah? This is also going to be a vertical line. This one goes straight up and down. So we'll just make a note of that. That was vertical, goes straight up and down. We'll come back to it later. This one, can I tell the slope of this one? This is y equals mx. This is actually slope-intercept form. It's just that my intercept is 0. That's why I can't see anything. This has a slope of -1/6. All right, so we'll keep that in mind, slope of -1/6. This is y equals 2x minus 9, so its slope is 2. Again, that number in front of the x for y equals mx plus b, so this is a slope of 2. This was -1/6. This is point slope form. Which one of these was the slope again? Ah, the 1/2. So this is a slope of 1/2. So this one has a slope of 2, this one has a slope of 1/2. Are those 2 perpendicular to each other? They are reciprocals, 2 and 1/2. If I flip over 2, I'll get 1/2. But are they opposites? That one's positive, that one's positive. Ooh, no, it's not good enough yet. Y equals 4. What do we know about this one? Y equals 4. Ooh, that looks kind of like this guy, right? So this was horizontal. So I'm going to make a note of that one. That one's horizontal. We'll come back to that. What about this one here? Y equals, again, mx plus b. This is my slope, is the -2. Do I have any sets here that are both opposite and reciprocal? This is a -2. This is a positive 1/2. 1/2 and 2 are reciprocals. So if I flip the one over, I'll get the other. And one is positive, one is negative. Ah, very good, very good. This will be perpendicular to this line right here. They have opposite reciprocal slopes. One's positive, one's negative, and they are flipped from each other. Do we have another pair here that are possibly also perpendicular? Okay, here's where life gets a little bit strange. I'm introducing strange things on purpose so that you have seen them before. That one doesn't even have a slope. So how do you take an opposite reciprocal of nothing? You really can't. But it's a good thing that you have a brain and can think, because if this line goes straight up and down, and this line goes left and right, guys, what happens when a vertical and a horizontal line cross each other? Ah, that also makes 90 degrees. So, because I know what shape they make, even if this one doesn't even have a slope, x equals 6 will be perpendicular with y equals 4, because vertical and horizontal automatically will cross at a 90-degree angle every single time. So anytime you mix a vertical and a horizontal, you will have perpendicular lines. Okay, all right, how you doing? How you doing here? I got one last thing, and it's crazy looking, and that's why I'm introducing it to you, because it's crazy looking, and I want to kind of remove some of the fear for you. The question is this shape a parallelogram? Well, okay, what's a parallelogram? Notice the word parallel. In a parallelogram, the sides that are across from each other are parallel, which means the sides that are across from each other have the same slope. So if I can find the slopes, I can figure out if it's a parallelogram. This notation here, this just says AB with a line over it. I'm saying the line that goes from A to B. Here's A, here's B, here's the line. What is the slope of this line that goes straight across? Goes straight across. Whatever could a horizontal line slope? Oh, that's right. It has a slope of 0. Hey, that's kind of handy. I didn't even have to calculate that. Could I calculate that one? Absolutely, I could. If you think about when we do y sub 2 minus y sub 1, so basically we subtract our y's, so that would be 2 minus 2 on top, and subtract our x's on the bottom, 3 minus -3 on the bottom. What's 2 minus 2? 0. 3 minus -3 is a positive 6, and what is 0 over 6? 0. So I can use my slope formula with these ordered pairs, or I can look at it and I can know this is horizontal. Horizontal always has a slope of 0. Okay, so what does that mean about this guy from B to C? So that's the next one, from B to C. What about this one? That's not horizontal. It's not vertical. So maybe we better do some calculations, all right? Again, we're going to subtract the y's on top. So I'm going to do -1 minus 2. And on the bottom, so if I did -1 minus 2 for my y's, I'm going to do 4 minus 3 for my x's. And -1 minus 2 is -3. And 4 minus 3 is 1. So -3 over 1 is -3. So this line right here, this piece, has a slope of -3, which, by the way, I can also see just by looking at it. To get from this corner to this corner, I'm going to go down 3 and over 1. Down 3 over run. I can see my rise over my run. So again, I've got options here. If you like formulas, great. If you like to be able to count things off based on images, awesome. Do it. Whatever works in your brain, that works for me too. C to D. Here's C, here's D. Again, that's straight across. What did we learn last time? Horizontal. Automatically has a slope of 0. And then the last side, the fourth side, connects A and D together. So if I'm going to go from D to A, what's going to happen here? Again, so maybe I'll do my math. And I can go with, let's go -1 minus 2 on top. Oh, that looks weirdly familiar. But then this is going to be, if I do -1 minus 2 on top, it's going to be -2 minus -3. -2 minus -3. Man, you got to really watch those signs, okay? -1 minus 2, that is -3. -2 minus -3, that's -2 plus 3. What's -2 plus 3? 1. What's -3 divided by 1? -3. Can I see that over here? Absolutely. From here to here, down 3 over 1. Is this a parallelogram? Are the sides that are across from each other parallel? Do they have the same slope? These guys both have a slope of 0. These guys are parallel. These guys both have a slope of -3. These guys are parallel. Is it a parallelogram? Absolutely, 100%. Yes. Yes, it is a parallelogram. There we go. So really scary looking. Take it one piece at a time. Don't let it overwhelm you. And yeah, more than anything, get this impressed in your brain. All right? Parallel, same slope, perpendicular, opposite reciprocal slopes. If you can get this in your brain, everything else from there on is doable. We can manage that. Okay? All right. Have fun. Practice.